For more than 40 years, the most distant explorers humanity has ever created have continued speaking to us long after their expected silence. Their voices do not arrive as strong signals. They come as faint whispers stretched across billions of kilometers, weakened by distance and delayed by many hours of travel through the vacuum of space. And yet, against all expectations, those whispers still reach Earth. Every fragment of data they send is more than information. It is a fragile thread connecting our small world to a region of space that once existed only in theory. These spacecraft were never designed for this kind of longevity. Built in an era when computers were primitive and memory was measured in kilobytes, their mission was supposed to last only a few years. Their objective was simple and finite: explore the outer planets, transmit their discoveries, and then gradually fade into silence as their power ran out. But space has a way of rewriting plans. Decades later, these aging machines continue their journey far beyond the planets, far beyond the fading influence of the sun, and into a region where the boundary of our solar system begins to dissolve into the wider galaxy. For a long time, scientists imagined this distant frontier as quiet and empty. A cold, silent void between stars. But the explorers traveling through it are revealing something very different. Recently, one transmission carried an unexpected mystery. Engineers had been struggling for months to understand strange incoming data. Clean patterns began to break apart. Structured signals dissolved into noise. It seemed as though the spacecraft's distant voice was fading, overwhelmed by the harsh interference of deep space. Concern grew. These machines had already survived radiation, extreme cold, and total isolation far beyond their design limits. It appeared the mission might finally be ending. Then, without warning, the signal returned. Faint. Delayed. But unmistakably clear. After traveling for hours across the vacuum, it carried structured information that could still be decoded. The spacecraft had not gone silent. It had recovered. It was still observing, still measuring, still revealing. And what it revealed is reshaping our understanding of the solar system's outer edge. For decades, scientists believed the boundary between our solar system and interstellar space was relatively simple. The Sun continuously releases charged particles known as the solar wind, forming a vast protective bubble around the planets. At its outer edge lies the point where this outward pressure meets the forces of the galaxy beyond. This boundary was expected to be smooth and stable. A quiet transition from one environment to another. Reality has proven far more complex. The data now suggests this boundary is not a single line. It is a layered and dynamic frontier. Instead of a clean edge, the spacecraft is moving through a region filled with shifting structures and fluctuating conditions. Plasma densities rise and fall. Magnetic fields twist, distort, and sometimes suddenly change direction. Conditions can vary dramatically over short distances. This is not a border in the traditional sense. It is a zone of interaction, a meeting place where the influence of our Sun collides with the forces of the galaxy itself. Even before communication stabilized, the spacecraft detected anomalies in this region. Its instruments recorded plasma vibrations where none were expected. Magnetic fields appeared structured rather than chaotic. Cosmic radiation fluctuated in patterns that suggested underlying order. At first, scientists suspected malfunction. Aging systems, degraded sensors, or corrupted data seemed like the simplest explanation. But the patterns kept repeating. The signals were real. The outer boundary of our solar system is not static. It behaves like a living structure. Some researchers now describe it as a flexible membrane that expands and contracts over time, influenced by both solar activity and distant cosmic forces. Moving through it is not like crossing a line. It is like passing through shifting territories, each with its own environment. This discovery changes our perspective in a profound way. The solar system is not isolated. It exists within a constantly changing cosmic environment shaped by distant stellar explosions, powerful winds from other stars, and vast galactic magnetic fields. These events send ripples across space that eventually reach our solar system's edge. In some regions, this protective boundary strengthens, shielding the inner planets from high-energy radiation. In others, it weakens, allowing particles from deep space to move closer to the Sun. The boundary moves. It reacts. In a very real sense, it breathes. Together, these discoveries are transforming how we understand our place in the universe. The galaxy is not a static backdrop. It behaves more like an ocean filled with currents, waves, and invisible storms shaped by forces we are only beginning to understand. And drifting through this cosmic ocean is a small, aging spacecraft. Each signal it sends takes hours to reach Earth. Each one is fragile, yet profound. With every transmission, the boundary of human knowledge expands. One day, its power will fade. Its instruments will fall silent. Its voice will disappear forever. But its journey will continue. Long after its final message reaches Earth, it will keep drifting through the galaxy for millions of years,